In this video, we will discuss the new VNX block deduplication feature included with the next generation VNX series. Before moving on to VNX block deduplication, we must first understand what data deduplication is. Data deduplication is the process of reducing the size of a data set by removing duplicate copies of data. The goal of data deduplication is improved storage efficiency. How is VNX block deduplication implemented? VNX block deduplication is run on a pool-by-pool basis, with each pool having its own deduplication process. Deduplicated LUN data is not compared with data from other pools on the system. It utilizes fixed block deduplication with a granularity of 8 kilobytes. 8 kilobyte blocks are compared, a single instance of the data is saved, and any duplicates are removed. Before duplicate data is removed, the LUN mappings for these blocks are updated to point to the data being retained on the system. When accessed, the I will be redirected to the shared block. VNX block deduplication is enabled on a LUN-by-LUN basis. Deduplication can only be enabled on pool LUNs, and the LUNs become thin when deduplication is enabled. On each pool, the user may pause or resume data deduplication. The user can also view the current state, view or update the tiering policy and deduplication rate, or view the current shared capacity and deduplication savings. VNX block deduplication runs post-process 12 hours after the last completed run on the pool. Each pool runs its own deduplication process. Before the deduplication process runs, the process checks for 64 gigabytes of new or changed data. If 64 gigabytes of new or changed data is not found, deduplication is not run and the 12-hour timer is reset. The pool metadata is checked for the 64 gigabytes of changes, which eliminates the need to check all of the deduplicated data within the pool. A maximum of 3 deduplication processes may run at a time on each SP. A deduplication process will run for a maximum of 4 hours. After 4 hours, the SP will check for queued deduplication processes. If one or more are found, the current deduplication process is paused and another is allowed to run. If there are no queued processes, the deduplication process continues to run on the pool. Listed here are the use cases for VNX block deduplication. Deduplication is useful on datasets which include large amounts of common data. This includes virtual environments, where duplicate virtual desktops exist, pools which contain LUNs with a large amount of duplicate data, or pools which contain multiple copies of data from a common source. Let's view an example of what VNX block deduplication can do. On my VNX array, I have 2 pools with the exact same configuration. Each pool contains a 1 terabyte LUN, one that has deduplication disabled and is thin, and one with deduplication enabled. Both LUNs contain the exact same 25 virtual desktops that my marketing group wanted for a project. Here is Unisphere for our VNX array. The pool which contains the non-deduplicated LUN has been selected. Let's look at the properties of the pool. Here we can see the current usage of the pool. The pool is currently 29% full and is using about 630 gigabytes of space for the virtual desktops. Let's close this window by clicking OK and enable deduplication on the LUN in this pool. To enable deduplication on the LUN, let's go to the Deduplication tab of the LUN Properties window for this LUN. To enable deduplication on this LUN, we need to check the Turn On Deduplication box. Click Apply, and accept any confirmation windows that appear. Click OK to close this window. Deduplication is now enabling on this LUN. Let's view the properties of the pool which contains the LUN with deduplication already enabled. For this pool, we can see the pool is only about 3.8% full, with only about 81 gigabytes used. Remember, this pool contains the exact same 25 virtual desktops as the other pool we viewed, but deduplication is enabled on the LUN in this pool. Let's view the Deduplication tab to see what it contains. On the Deduplication tab, we can see the current state is pending, which means deduplication is currently waiting for the 12-hour timer to expire so deduplication can run in this pool. We can also change the tiering policy for the deduplicated data and the deduplication rate, which is the speed at which the deduplication process runs. Lastly, we can see the share capacity for the deduplicated LUNs is only 46.7 gigabytes, and the savings from deduplication is 579.7 gigabytes. This means that we only have 46.7 gigabytes from the original dataset on disk, with 579.7 gigabytes saved due to enabling deduplication on this LUN. Savings achieved here depend entirely on the data being deduplicated. This completes the VNX block deduplication video. For more information on VNX block deduplication, please view the EMC VNX deduplication and compression white paper found on EMC Online Support.